Hi everyone, our topic for today is about integration by parts. So at the end of this lesson, you should be able to identify U and dB from any given integrals using the acronym LAYATE and evaluate integrals using integration by parts. Okay, so one of the most interesting techniques of integration is the integration by parts. So in this method, suppose you're given two differentiable functions of x such as u and b. And then if we take the differential of this product UB, we get UDB plus BDU. And if we solve for UDB, we transpose BDU on the other side. So you get UDB equals the differential of UB minus BDU. And then if we take the integral of both sides, we get integral of UDB equals the integral of the differential of UB minus the integral of BDU. But we know that the integral of the differential of UB is equal to UB. So therefore, the integral of UDB is UB minus the integral of BDU. And this formula is called the integration by parts. And to evaluate the integrand of this form, the integral of UDB, the main goal is to choose U and dB now to obtain a new integral that is easier to evaluate than the original. So a strategy that often works is to choose U and dB so that U becomes simpler when differentiated while having a dB that can be readily integrated to obtain B. So there's another useful strategy for choosing U and dB that can be applied when the integrand is a product of two functions from the different categories. So these categories are the logarithmic, the inverse trigonometric, algebraic, trigonometric, and the exponential functions. So what you have to do is you take U to be the function whose category occurs first in the list and take dB to be the rest of the integrand. So this acronym LAYATE will help to remember the order. So L stands for logarithmic, I for inverse trigonometric, A for algebraic, T for trigonometric, and E for exponential. So this method that does not work at all times, but it proves to be useful. Okay, so to apply the integration by parts, so let's have the following example. So number 1, evaluate the integral of x cosine x dx. So as you can see, because the integrand is product of algebraic and trigonometric function, so this can be integrated using integration by parts. And to choose U and dB, we have to follow the acronym LAYATE, where L stands for logarithmic, I for inverse trigonometric, A for algebraic, T for trigonometric, and E for exponential function. And because this contains algebraic and trigonometric, we have to look for the category that comes first. So in this order, because algebraic, which is is written first before the trigonometric function, so we let U be the algebraic function, and then the rest of the integrand as dB. So we have dB is cosine x dx. And then from U equals x, we take the differential of both sides. So du is dx. And then for dB equals cosine x, we take the integral of both sides to get b equals sine x. Now recall that the integral of cosine x dx is sine x. And then using the integration by parts formula, wherein we have the integral of UDB is UB minus the integral of BDU, where U is x and B is sine x. So we have x sine x minus the integral of B du, where B is sine x dx. So this can now be written as x sine x minus, recall that the integral of sine x dx is negative cosine x. Okay. and then plus the constancy, and this is equal to x cosine x dx. So simplifying further, so this is equal to x sine x, negative negative is positive, cosine x plus the constancy. So therefore, the integral of x cosine x dx is x sine x plus cosine x plus the constancy. Okay, for number 2, we are asked to evaluate the integral of natural log of x dx. So the integrand only contains a logarithmic function, but we can still use the integration by parts. Okay, so in this case, there's no other function given in the integrand. So we let u be the natural log of x and then db as dx. And then from u equals natural log of x, we take the differential of both sides. So du is the differential of natural log of x, which is 1 over x times the derivative of x, or differential of x is dx. So you have dx over x. And then we take the integral of both sides to get b. So b is equal to x. Okay. And then following the formula, recall that the integral of u db, where u is natural log of x, and then dx is your db, is equal to the product of ub, where b is x, times the natural log of x, minus the integral of b du, where b is x, and then du is dx over x. And then simplifying further, so this can be written as x times the natural log of x minus, cancel this out, so you have the integral of dx. But the integral of dx is x. So you have minus x plus the constancy. So therefore, the integral of the natural log of x dx is x natural log of x minus x plus the constancy. So in summary, Layate is a useful strategy in choosing u and dv when the integrand is a product of functions from the following categories. So we have logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential functions.